Happy to see surprising amount of people actually for the late night last night. But you're gonna be well rewarded because we're gonna have 3 excellent presentations today, all focused around big data analytics in research and education. First up is a local Professor Barry Smyth, who's going to be talking to us about data analytics and big data in education. Professor?
Yep. Thank you. So good morning, everyone. It's good to see you all here today. As you just heard, I haven't had to travel as far as most of you, about 50 meters from my office to get here. So I guess this is my home turf. And I'd like to talk to you about some of the work that we're interested in the general area of big data and data analytics. Now, let me make sure that is that the right one? Okay, there we go. Wasn't switched on. Technology, hey? So I lead a large research group called Insight. It's a new research center in the area of data analytics, and it's we're about 250 researchers at the moment, and we work with across 8 different institutions in Ireland, and there's a lot of industry-facing work as well as basic research going on. So I'll just touch on some of the things that are of interest to us in Insight and bring the discussion around to some of the ways that we see big data impacting on the educational sector. I think it's interesting to think about how much data is generated in all of our lives every day. And even if you think about the last few days in this conference, the talks you've attended, the people you've met, the demos you've seen, and all of the different data points that might be generated and captured and recorded and stored and retrieved at a later date. And it gives you some insight into why people get excited about this big data world. I'm often asked, how much data is there in the world anyway? And it's a very difficult question to answer accurately. We certainly need to be thinking in terms of exabytes, which is 10 to the power of 18 bytes, which is very hard to put into any sort of sensible scale for context. But one way you might think about this is that it's about 20,000 times all of the printed material in the largest library in the world. That's 1 exabyte. Or if you want to look at it another way, an exabyte is around about all of the words that have ever been spoken by humans. But we're creating this much information every 6 hours, and that pace is only increasing. So big data and data analytics, it's not just about the scale of the data, the volume of the data, it's also about the real-time nature, its velocity and the sheer variation and variety of data that has been produced, and our ability to look at that data and to detect interesting patterns, and then to turn those patterns into decisions and actions. So I'd like to very briefly talk about how we've got here today in terms of big data. We've been dealing with data for many, many decades, but in the past our data sets have tended to be small, they've been clean and uniform, they've been curated for a particular task, a single use, and it's all been about causation. And these days we look at data very differently. We try to collect as much data as possible. It's messy, it's diverse, we reuse it in different ways, and while we're still interested in causation, very often we're just interested in correlations and identifying correlations that exist within those data fields. In many ways, the all-important algorithm has become less important to the data. So now we find that techniques, simple algorithms, relatively simple algorithms, which would not have worked very effectively in the past, start to work very efficiently and effectively when we present them with huge amounts of data. All of this is driven, of course, as you're familiar with, by the huge changes that have taken place over the last few decades in terms of our computational abilities. And Moore's law foresaw that we would move from a power-to-price ratio of about 0.05 floating point operations per dollar in the 60s up to today, where your iPhone is delivering about 8 million floating point operations per second per dollar. So a very huge pace of development over the last few decades. Again, it's easy to forget how more powerful and how much cheaper our devices have become. If we put this into the context of something that's a little bit more familiar to us in the auto industry, it's often said that if the auto industry had moved at the same pace, had developed at the same speed, then we'd be driving around in cars today that are delivering about 1 million miles per gallon. And you know, at the end of the day, instead of paying parking fees overnight, we'd just throw them away and buy a new one in the morning. So I think that puts this into context. The really interesting part to all of this for me is how data is starting to invade our everyday lives. I'll talk in a few moments about the implications of that for education, but I'd like to look at healthcare as one other aspect that is being, or one other market that's been fundamentally disrupted by big data and an app-driven culture. And I think you're all familiar with the type of apps that we're using now to monitor our own personal health and well-being. The run keepers of this world, you'll see people jogging and cycling and strapped to their arm. They'll have their mobile phone and it will be tracking every step and every revolution of the pedals. As well as that, it knows our age and our gender and our weight. It knows our location, the pace, how much time we're spending in the saddle every week, the calories we're burning, perhaps even our heart rate. This is a minefield of information for the healthcare industry. We're even having phones now on a simple smartphone, apps on a simple smartphone, which are free to download, which can take our heart rate, not with some external heart rate sensor, but through the camera that's on the phone. So you place your finger over the camera lens, and it's accurate enough to detect subtle changes in skin color arising out of changes in the underlying blood flow and track that back to heart rate. And it's able to accurately measure your heart rate straight from the phone on your mobile camera. Another interesting example is lung function tests. There are apps now in development where the patient or the user will blow across the microphone of their smartphone, and based on the audio signal that is detected, the app is able to do a lung function test within about 5% clinical accuracy, which is certainly good enough for home monitoring of people with lung issues, for example, all from the microphone on your smartphone. We're tracking our sleep. We're even tracking our mood and focus, although I'm not quite sure how many of us will be prepared to wear the unfortunately named melon headband in order to detect our mood and focus, but it's beginning to connect up with things like engagement. So imagine if we knew the extent to which students were paying attention in lectures or as they engaged with course material. I think we'd be shocked and horrified if we really knew that. But all of this is very exciting. All of this is bringing new data potential to the healthcare industry. Imagine walking into your doctor's surgery in a few years' time and bringing with you all of that data and going away with an app rather than a prescription because your doctor wants to track some other aspect of your health. It's particularly interesting when we start to scale these up and we add app after app to look at sensing more about the individual. And then when we, of course, realize that these mobile phones are connected devices, we can start to sense across populations. And we can develop all sorts of interesting sensor network applications. One very interesting one to me is the Opolis smart inhaler sensor, which is a simple dollar sensor which inserts into a standard rescue inhaler. And it just detects when the inhaler is used, but it connects to a smartphone. And a smartphone has location information. So now, as well as helping to manage the medication for the individual who's using the inhaler, use of that inhaler across a population of sufferers, and you start to develop a real-time air quality map. You start to develop the sort of air quality sensing network that would cost millions to produce if you were to deploy traditional sensor network technologies. So that gives you some insight into some of the ways that big data is coming into contact with many aspects of all of our lives, health and fitness in particular. One of the other areas that's particularly interesting is education, of course. And there's a huge amount of data being generated by students, by instructors, by publishers, by institutions. And we're only beginning to scratch the surface of some of the ways that we can start to use that data and harness that data to deliver a better educational experience for the students, for the instructors, etc. And I just want to give you some concrete examples of what people are doing in this regard. Very interesting work at Purdue University, a system called Course Signals. And Course Signals is integrated with Blackboard and other student information systems that they have at Purdue. And it's able to profile students in terms of the preparatory work that they do for courses, their engagement and their effort, and then to come up with a retention risk predictor. So the idea is that you want to try and identify and flag for students if they're falling behind or if they're likely to fall behind. So in a particular semester, the instructor may set up course signals to provide feedback at particular intervals in that semester. And up until that point, we'll have profiled students based on their preparatory engagement, etc., and we'll give them some early warning sign. So it'll look at things like time they've spent on particular tasks, their past performance in similar courses, their score so far in this course. Very simple and obvious pieces of information that can be captured in a continuous basis in real time. And then using a fairly simple predictive analytics approach to provide feedback, red light, amber light, green light to the student to say things are going fine, or maybe hold on a second, you're not spending enough time on this particular topic. Here are some additional readings you may want to look at. Here's some additional tests you may want to take. And it provides very early warning signs to both the students and the instructors about those students that need a bit more attention, for example. When they deployed this, they found some very significant increases in the performance of students. So the top grades were increasing by up to 28% in some of these courses. And the most significant grade improvement were seen in those students who were tending to get C's and D's, who generally increased by a half-letter grade improvement as a result of this type of timely intervention. Not particularly sophisticated data analytics, not requiring a huge amount of data, but a sensible approach to using the data that can be collected, and then a good way to present that feedback to the students in a fashion that they can start to take action. Obviously, we're all familiar as well with the disruption in our own sectors around massively open online courses. And one of the very interesting things here, as Daphne Kohler and Andrew Ning have recently talked about, they're the people behind Coursera, they talk about the 2 sigma problem. And this is trying to move the average performance of students who are taking courses by 2 standard deviations. And all of the research over many decades has shown that particular students, as they engage in course material in a traditional lecture, versus when they move through a course using mastery-based methods, so they can only move on to the next topic once they've demonstrated their mastery of a particular topic, versus individual tutoring. And individual tutoring shifts the performance scores by 2 whole standard deviations, so you're upping the average of students in a very significant way. In a lecture-based context, only 50% of the students, by definition, have above median performance. With individual tutoring, you can shift that so that 98% of your students are performing above the average in a lecture context. Imagine if we were able to deliver material so that 98% of our students were able to perform above average. Well, this is the promise of personalized tutoring systems, where we understand, where we profile students' abilities and their interests and develop more personal pathways through course material, or identify courses that are better aligned with their skills and preferences. And there is very standard and well understood technologies in the recommender system space, for example, for developing personalized approaches to content discovery and recommendation. We know this because we come into contact with them through sites like Amazon and iTunes. You know, people like this have also liked this particular book. But the same technologies can be used across students and items, which instead of those items being books and movies or music, those items become courses or sections of courses or questions. And we can start to profile students to identify correlations between the particular engagement patterns of students across courses. So students like you have also enjoyed this particular course or have done well on this particular section of the course. This is the type of output that a recommender system can give us. Conversely, correlations between the patterns across the courses rather than the students denote course-to-course similarities. If you liked course X or section Y, then you might also like course Z, for instance. So these are well-worn technologies that are now beginning to be applied in an educational setting to deliver more personalized approaches to learning. One of the challenges that we have to deal with when it comes to delivering large-scale education outside of the lecture theatre, and think about these massively open online courses and the hundreds of thousands of students that are taking them, potentially, 100,000 students taking a course at any given session. How do you even begin to grade those students and what they're returning? And the interesting thing here is that it's been well shown that peer grading and even self-grading approaches under the right conditions can deliver grade qualities that are as good as teacher-based grading approaches. So this is how systems like Coursera are managing the grading problem. So peer grading systems not only deliver grading at scale, but they also help the students themselves to better understand the material that they're engaged with. Other interesting things that you can start to think about when you look at this data at scale, when you have thousands of people answering questions on courses, you can start to detect patterns in wrong answers. So this is, again, an example from Coursera, where the plot here looks at different answers to particular questions. In this case, there was sort of two numbers that provided the answer to a question, so it's easy to visualize it. But the X's denote wrong answers. And that large X at the top left is an example where 2,000 students all made the same mistake, all gave the same wrong answer. Now, if 2 or 3 students in your class gave the wrong answer, you'd probably think nothing more of it. But when 2,000 students give the wrong answer, you start to think, what is it about the course material and that question that they're misunderstanding? And it allows instructors to go in and to understand what's going wrong and to provide targeted feedback. So automatically now, when a student answers a question incorrectly in that way, they get targeted feedback about what the instructor understands to be the problem. So you're getting a much richer form of feedback for the student. There's a huge change in the tools that we're using in an educational setting. Who'd have thought that you could start to do pharmacological studies using search logs? This is what one particular group of researchers did. They were looking to identify side effects between particular drug combinations. Instead of doing clinical trials, they went and looked at search query patterns for cohorts of patients that were taking those drugs either in isolation or in combination, and were able to detect, in this case, a much higher incidence of hyperglycemia searches for people who were taking both drugs in combination. And this side effect turned out to be confirmed by later clinical studies. All of that was through search engine analysis. Google's Ngram viewer, which allows you to look at word usage over decades and in fact centuries of literature, is changing the way that people are conducting cultural studies, for example. Look at the pattern of changes of joy versus sadness, or fear versus disgust words over the decades, and correlate those with interesting global events. And the thing that's really interesting is how big data is leaking into all of these other disciplines. Cultural studies, ethics, politics, language. It's not just about computation, computer science, and statistics. Changing tools, we're also changing the way that people are searching for information. We're so used to Google and Bing, but we still find it hard to get what we're looking for. This particular session is about people working together, and making search more collaborative is an important way forward, because we realize that most of the time when we're searching for something, one of our classmates or colleagues has already found it. And we've been able to develop collaborative search services that work on top of Google, so that when you query for something, as well as getting the Google results, you're also getting results that people in your class or colleagues have found useful for similar queries. And we're able to show that the relevance of those results is much greater than the organic Google results on their own. So here you can see a particular query. In this case, it's for restaurants, and there's the Google results. And there's recommendations that come from the collaborative search component. It's the same Google. You're still searching the way you've always searched, but now you're tuned into the search patterns of communities of people, be they classmates or colleagues, that have similar interests to you. And we're working with the Learnovate Centre, which is an e-learning centre here in Dublin, to build this technology into curation tools for instructors so that they can build course material and also provide collaborative search services through Google and Bing and the likes. And I don't have time to go into that in a huge amount of detail, but hopefully you get a sense of that. So what I've tried to do is, this has been very much a whistle-stop tour of some of the ways that big data and data analytics are coming into contact with our lives and into contact with the lives of students and instructors all around us. We're only scratching the surface. We're beginning to realize that there's huge potential. We're beginning to develop the tools that are needed to take advantage of this potential. We're starting to realize that we can generate real insights into how people learn and how people are educated by modeling their behavior, by tracking their behavior, by modeling their behavior, by using those models to deliver improved educational experiences, targeted instruction, personalized educational feedback and pathways, better identifying when students are failing or when they're likely to fail, so that we can do something to turn that around. And all of this is moving in the direction of transforming education from the standard sort of lecture-based paradigm into something that allows us to move average performance in the direction of that sort of 2 sigma phenomenon that I mentioned earlier. I'd like to conclude by saying, we need to be careful in how we use data. And clearly, it's easy to become too enthusiastic about all of the data that we can start to capture, and on the other side, overly concerned about the ethics, the privacy, the security aspects of all of that. As a society, we need to figure out what the right balance is here. What can we track and what can we use versus what should we track and what should we use? And let's always think about why we're using this data and the purposes that it's been used for. Are we actually trying to improve somebody's lot, which I think is particularly important. I've no doubt that the educational sector will continue to be transformed by big data. I think there's the cat is out of the bag on this one, and we all need to figure out how we want to be involved in that and how we want to support that. I think there's real major opportunities in the area of personalization and participation through new tools and collaboration, particularly in the context of distance learning. And I think this speaks to a very exciting few decades ahead of us. I'll stop there, and I'm happy to take any questions that you might have. Thank you very much.
So thank you very much for that. Questions? Got one right there.
Thank you for the very interesting presentation. When I was looking at your slides, I was thinking back to my time at university teaching, and I was thinking maybe there were some things in there that might have been really helpful there to enhance the performance by the students. Maybe more like a note to the Google stuff that you had in there and the personalized search, because I think while this may be an opportunity, there's also some, let's say, drawbacks involved in there, because even with Google right now, you have some kind of personalization in there, and this certainly leads to the phenomenon of filter bubble, so that you're finding what Google thinks you should find, and personalizing this more, you'll find what your peers find, and maybe you're not finding what you should find.
Yeah, yeah. I think that's a very good point. And for those who don't know, The Filter Bubble was a book that was published a couple of years ago. There's a very good TED talk by the author on this, and the premise was that we're becoming blinkered in the discovery tools that we're using. And if I search for Google, I'm getting a very fine-tuned, filtered set of results. And should we be worried about that because we're not exposing people to a full diversity of opinions and a broad spectrum of opinions? And I think that's a valid concern. And I think I don't have a good answer for that other than the platitude of saying it's all about getting the balance right. And clearly we need to look at, especially in an educational context, challenging students with alternative opinions. Prodding them to think differently about the world is clearly important. That's why I think one of the things that we've looked at in that collaborative search tool is precisely that, that by connecting you in to other communities of users, they're not necessarily like-minded students. They don't necessarily think in the same way that you do. And sometimes we're surprised by the different types of results that are surfaced in those recommendations compared to the organic results, precisely because you have a student who's different in the class.
Thank you. Anyone else? I was going to ask something about privacy concerns here, but I think you sort of already covered it. So, there's another question. Actually, I think you could probably, if you get heard. Oh.
Thanks. It was a great presentation. I just wanted to know your opinion, just getting a little bit ahead of what I'm talking also. What do you think pragmatically, the time frame to actually implement this, for instance, at UCD?
Yeah.
For this kind of technology, this kind of retention system or alert to that? What are the pain points that you foresee and the time frame for implementation?
So I think the pain points are not technological.
Yeah.
The technology is rather straightforward, sometimes embarrassingly so. The pain points are usually institutional and usually for all the right reasons, making sure that we're approaching the problem in the right way, making sure that we're using data in a sensible way, being fully aware of individuals' rights to privacy, etc. There are all sorts of ethical problems as well. If the wrong intervention can be more damaging than no intervention at all in a student's learning life, for example. So I think we need to. There will be a lot of a rush to experiment, and that's what we're seeing now. Yeah. And we'll see fragments of good ideas. I think the course signals at Purdue seems like a very sensible approach. How all of that will connect up into a data-driven university in the future remains to be seen. But it's a very exciting time ahead. And I think we will inevitably see ourselves moving in that direction. We need to be careful. You run the risk of everything becomes automated and data-driven, and that's not what it's about. It's about really using the data to fill in the gaps that currently exist in the system and to make it much more efficient and pleasurable for the students and the instructors and everyone else involved.
Yeah.
Okay. I think we'll give another
Thank
round
you.
of applause for that. And welcome Herman Stehouwer to the floor, who's going to talk to us about the Research Data Alliance.
Yes. Hello, everyone. I'm here to talk a bit about the Research Data Alliance, which is a worldwide forum thing, which I'm going to briefly explain how it works and what it's been producing so far. But keep in mind that we are very, very young. We've existed for slightly over a year and a half now, so don't expect anything too fantastic yet. Well, of course, it's fantastic. I mean, but the first question is, why are we doing this? The simple answer is not the very nice quote that we have here, but because data exchange is not working at the moment. People don't even know what data is out there. And if they have data, it's often not very well described. There's just a lot of problems exchanging data. And we need this data to solve problems. But, yeah. So what we are a forum that tries to tackle these things by bringing people together worldwide to solve relatively small problems. So not too large. And we have a vision and a mission, and if you care, you can read it later if I get the slides on the website, because the ones that are up there now are corrupted for some reason. But so how does this work? We have two types of vehicles. We have working groups and we have interest groups. These get created and they come together at least twice a year in order to discuss whatever their topic is and to make progress. These meetings happen at our plenaries, where there's also ample opportunity to have birds of a feather session, other types of breakouts, and all kinds of discussion. So working groups are very structured. They are moving towards trying to solve a small problem, which has a clear adoption plan, and so forth. I will give some examples later. Interest groups, on the other hand, are vaguely defined. They're groups that care about a certain topic. There's not much governance around them. They also last longer. They are used for various things, for instance, to have a place to come together to talk about metadata in general and not about a specific metadata problem that is being solved. But also to have a collaboration with, for instance, codata in one of the cases where if we would have a shared working group, it wouldn't work together with their pre-existing structures. So this was then the easiest and most flexible solution. So currently we have 10 working groups. I should have updated this slide as well, but I just saw, we just approved one yesterday. So it's 10 working groups and 24 interest groups at the moment. And this includes joint groups, both in the working groups as in the interest groups, but joint groups tend to be interest groups more than working groups. On the other hand, we tend to have more interest groups than working groups anyway, so that's not that weird. We are going to have some first deliverables soon. And with soon, I mean this year. These 4 groups will deliver something which will be adopted and which will make stuff work slightly better. So I'll just go through them briefly. The Data Foundation and Terminology group is very simple, trying to define a common terminology so that we can actually talk about these data issues together. In order to do this, they have investigated how people look at data, what are their data organizational models. They found some 20 different-ish ones in use just within our community. So this is a fairly large undertaking, and this terminology will be used internally by the other groups. But there's also been external adoption by, for instance, OIF, EUDAT, and DASHIS. So that's people or groups that have agreed that they will, maybe adopt it, right? I mean, no one's going to say we will adopt whatever comes out, but that there's the intention at least. There's the data type registry groups. They try to federate between several pre-existing data type registries. So these are registries that contain more formal descriptions of data types, so you can do some computer automated actions on them. There's the PID information types. They're trying to define core informational types that should be associated with certain types of PIDs. And with types of PIDs, I don't mean from different PID systems, but for instance, what should be associated with a PID that points to a journal article, what should be associated with a PID that points to some data, and so forth. Of course, we already have an idea about what should be associated with a journal article PID, and you should have which journal, which authors, and so forth. And they are building a protocol and an API implementation in order to be able to ask these things from any PID system, well, assuming they're present. But, and there's the practical policy group that will be delivering this year, which is building example policy sets. And policy here is computer actionable policy. So stuff that middleware uses in order to do stuff automatically with data. And this group is mainly adopted by its own participants who like to see what the other participating data centers are doing, and maybe they have small gaps, or it could be done slightly more efficiently at their data center. They do have similar wishes. For instance, the data centers agree that they care most, and they want to do first a nice policy set on how to automatically do replication, which is actually fairly complex. So far, all these deliverables seem to be fairly technical, and the first year is going to, the first round is going to produce mainly technical deliverables, but they don't have to be technical. There's one nice example, which happens to be the group that was approved yesterday for the data seal of approval and WDS group on certification. So both the data seal of approval people and the WDS people have a self-reporting certification for archives. This builds, if an archive has been certified somehow, this builds a certain amount of trust. This gives a certain expectation of quality, and so forth. And these people found out that they have very, very similar certifications, and they are going to compare and try to merge it, which should be a big advantage to if these things are a bit more transparent and you have less different certifications. This is also clearer to people that might want to deposit some data at the data center, and thereby you will get even, well, more trust. So recently, in February, we had a workshop with some 15 leading scientists on what they thought were the problems with data sharing, which I can sum up in 3 major issues. First, trust. Do you trust the data center and the data? Is the data that comes out the same? How was it produced, and so forth? Credit. They need to get career credit for their work. Not just that you... Well, I mean, it's very nice if colleagues use your data sets, but if this means nothing for your career, you're not going to do it anyway. And thirdly, they care about longevity. Preparing a data set for archiving is a lot of work, which currently doesn't get much credit, but if they do it, they would like it to be available for at least 15, 20 years or more. Otherwise, this is again a wasted effort. I have a nice little glossy thing with the conclusions of this of the report of this workshop. I have a small pile of them, so if you care, you can get one of them, and this is always nice support material if you're writing a proposal or something like that. I mean, they've concluded stuff that's fairly well known and people generally tend to agree with, but yeah, it's nice support material. It has more authority than some data guy saying this stuff, unfortunately. So there's several ways of looking at the groups we have. we're starting to get at a point where we are growing quite fast in the number of groups, and maintaining an overview is starting to become hard. This is a taxonomy which was proposed by Peter Wittenberg, where we have cross-discipline groups and discipline-specific groups and technical, non-technical, and then on even more fine-grained areas. Beth Playley proposed this way of looking at the groups, where you can have focus on domain science, on community needs, on sharing and data references, on maintaining data that is there or getting it archived, and of course the base infrastructure, the data fabric. And there's even a third option. This was proposed by Juan Bicarigo from STFC. I'm sorry if I pronounced that name wrong, by the way. But luckily he's not here, so that solves that problem. Where you can, I don't know if you can see the pointer, where we have a tree which represents the data landscape, and you have data producing groups, or groups that make sure that data is accessible and findable and so forth, and you have data consuming groups, which I should have mentioned first apparently. So these data consuming groups, they use the data that is made available, findable, exchangeable by the data consuming groups, and thereby they can make new science happen, or answer questions that we couldn't answer before. And we are then the trunk that brings those groups together. That always sounds very nice. So what can you do? You can become a member of the RDA. You can participate in working groups and interest groups, or just in the discussion. Becoming a member is free. You only need to agree to the principles. Organization can become a member, and then you can talk to other organizations which are a member on adoption and so forth. We have had 3 plenaries so far. The first one was in Gothenburg in March 2013. So as I said, we are very young. That was a fairly small conference with some 200 people. Then we went to 400 people. Earlier this year, here in Dublin, in Croke Park, we were more than 500 people. The 490 is not completely accurate. And later this year in Amsterdam, we expect to be around 500 people again. And that will be 22 to 24th of September. But we will have a data week. There will also be the EUDAT conference, and there will be many other smaller events there as well dealing with data. So that's a very interesting week to go to Amsterdam. So please look at the web platform, interact with us, and become a member. Oh, I cannot go one slide back? Yeah, thank you. I think I'm done very quickly. Sorry about that. I tried not to talk too long, because sometimes I go way, way over time. And now I'll go way, way under time.
But that just means there's more time for questions.
Yes.
So let's do. And I see we're going to have a long discussion because...
No.
Thanks a lot. Actually, you were in my radar for quite some time. I'm not doing Victoriano Giralt University of Malaga and some other hats. I do not deal with research data, but I deal with student data.
Yes.
And you have said something that also the previous speaker has said. You said curation, and you have said preservation. There was in your tree slide, underneath there was preservation. And that's something that worries all the people that is dealing at the moment with all these student records. We are starting to worry, what will happen to all these data in 20, 30 years' time? Paper, which I'm against, is there. You can go to the library, you can grab the books, you can research. What will happen to all the data we're producing? What will happen if in 50 or 60 years we want to know what degrees got someone that became famous? How would you solve the preservation problem? Or what are you thinking about that?
Well, that's a problem for the university itself to start with. However, we are talking about fairly structured data. So you know what you want to store. You can do this fairly neatly. You have a student who has a unique student number. And if you're out of student numbers, you just make them one longer. Seen that happen a few times. But you can generally try to store these problems quite okay. Storing these kind of things is not too hard, but it needs to be a priority. For instance, there are long-term archives which have a fairly long guarantee, like the ARC project in France. There's the language archive for endangered language materials at the Max Planck Institute in Nijmegen, which has a 50-year guarantee. There's the data archiving in the Netherlands, which has been happening for 50 years now. So these are things which are possible if they are a priority, and meaning that it costs money. The problem with data archiving compared to paper archiving is, of course, that you cannot just let it slouch for a year, because if you stop spending money, it goes away. But at least you have structured data here. If you're dealing with unstructured data or not well described data, then in 2-3 years, if the person that made the data goes away, you no longer know what this is. But, you know, I go off on things, never mind.
So these things are connected off these projects you've talked about would be connected through your website, so we can use pointers and find about all those interesting things that you have said, the language preservation and the...
Well, people from there are involved, but and there is a group that cares about preservation. So you can talk to them.
Great. Thanks.
More questions? I'll ask. Oh, there.
Thank you. I'm from Brazil, although I speak perhaps like an English person. And I know of RDA from some remote contact, but I know there are some Brazilians who have been at some of your meetings. But I don't think that knowledge about this initiative has widely spread there. And I was wondering whether you have on your roadmap any kind of indoctrination or similar dissemination schemes for countries which aren't currently involved so much.
Yes, we do, in fact. Currently we have only the US, Europe and Australia, which are the 3 areas that came together to start this thing. Well, there was an initiative in Europe and there was a very similar initiative in the US. And they decided to join some 2 years ago. And the Australians with the National Data Service there, ANS, they also joined in. But currently there is a strong expectation that it's going to be a much larger group within the next year, with probably Japan, China, South Africa, and so forth joining. We're working on Brazil, but I don't know how or when they will join, to be honest, or if even. But there are active efforts from all parties, including at the G8 plus 05, 06 now? All right. Russia's back then? Oh, okay, fair enough. We're at 06 again. But they have this working group on data, and that's also being used for dissemination about the ministers there have been briefed and so forth. So, but all these things take quite a bit more time than one would wish. Yeah.
Alex Reid from ARNet in Australia. RDA actually stands for Research Data Australia. I think we had the acronym before you did, but never mind. Can you tell me how, I mean, mostly it seems to me that RDA is a talk fest.
Yes.
They're not actually developing anything other than policies and guidelines and so on. Are you actually working with the standards bodies, OASIS and the others that determine standards in the data preservation field? And if so, how are they connected? And are you not duplicating work that they're doing?
No, we are not duplicating work, not as far as I am aware, and not as far as the Technical Advisory Board is aware, which is much more experienced and wiser than I could ever be. But no, I don't think we don't want to duplicate efforts. And we are not the place for all the problems. There are many other places which exist, which might be better for a specific problem, like OASIS or ISO or W3C or IETF. It depends on your problem. We are very much for having more data exchanged by solving something relatively small. And issues of preservation are, of course, essential if you're talking about data exchange, but that's not our primary focus.
I'll add to that just before the RDA was formed, or right when it was formed, some of that community did turn up at the IETF to run a BOF around digital object identifiers. I don't know that anything ever came of that, but there was a certain amount of discussion. Names and numbers is certainly one of the areas where experience from the internet has shown us that coordination it's the name of the game, right? If you can't coordinate on names and numbers, then it's not worth doing.
Persistent identifiers are considered essential.
Yeah.
However, they are already there.
Yes.
They need to be used.
There used to be this thing called the handle system.
Yes.
I mean, there are many of these that sort of predate what the RDA is doing, and there's been a fair amount of conflict and controversy around several of these systems in past. So
some of the people involved in the RDA, like Larry Lanham from somewhere in the US, and Peter Wittenberg, people from DataSite, are starting something they call the DONA board, which is a worldwide board for PIDs, which includes people from China and all the parts of the world, and decouple the ownership of the system from a country or specific institution setting, have local geographical minting authorities. I don't know, whatever you want to call them. I don't work on PID, so I'm not completely up on the jargon. But they're working on these problems, and these are partially the same people that are involved in this initiative, but it's just different.
Other questions? Or we'll thank you again for your very good presentation. And last one up today is Elsa Cardoso, who's going to talk to us about business intelligence, the state of the art.
Thank you. I'm just going to start. Okay. Well, morning to all of you. And I'm now going to talk about something a little bit different, although totally connected. Well, at the same time, different but totally connected. Okay, now I have your attention. So basically, what we're going to talk is the work that we've been doing at EUNIS, specifically on the Business Intelligence Taskforce. And we're going to present you what EUNIS is and what this Taskforce, why it was created. And the first project that we've been doing, which is analyzing the critical success factors and assessing the BI maturity of BI initiatives across Europe in higher education institutions. So we're going to talk about a little bit of the results of the survey that we did last year. So EUNIS is a European organization that has the mission to exactly being this collaboration and get together and bring universities together to develop their IT landscape. And it's active for 20 years now, and there are some other people on the audience that are very active in EUNIS as well. So we are now organized in task forces, and one of the task forces which I am leading at the moment is the BI task force, which was set up to promote the creation of an European online platform to exchange and share knowledge and experience on BI in higher ed institutions. So in order to start this, I thought that we needed to know the SE situation. Where do we stand? We have a lot of ideas. We know that we have a lot of interesting time ahead of us. Since we look at the first presentation we had, the big data challenging, other challenges that we have already discussed today, also the preservation challenge that no one is actually at the moment too much thinking about it. So we decided to start this BI maturity survey, and we had a conference in last March in Paris where we presented the preliminary results, and the final results will be presented in our annual congress that will take place in Sweden in June. An upcoming event is already tomorrow here at UCD, and I invite everyone who wants to participate. We will meet with Irish universities and look and try to understand the results of the survey for Ireland. So if anyone is interested in participating in an open workshop, we can actually contact these persons. So what about the maturity survey? It actually started running in 4 countries, but then it escalated and we got it running in 9 countries. But before we get into delving into the issues of the maturity survey, I'm going to go a little bit of an overview of what I think is BI for me and the critical success factors and maturity models in order for us to be all in the same pace. So in terms of BI, because today we talked about big data, we talked about other things. What is BI? Well, for me, BI it's all about gaining more insight into your organization or your institution. So it encompasses a broad category of applications, technologies for gathering, storing, analyzing, sharing, and providing access to data to help us with a drive to help us make better decisions. I'm also always very pragmatic, and I think that we all know that we have a lot of data, but how much of that data actually help us improve the decision-making process in our daily job? So it's also BI, it's also linked to achieve the organizational goals. What are your organizational goals in terms of whether a research institution or university? Do you have the required systems to help you achieve those goals? That's why we mean by BI systems. So when we talk about BI, I always use this framework with it's very simple, 4 layers here. We have different source systems. We then extract, transform, and load into a data warehouse, which is an integrated repository. And then we have the BI or the BI application layers used to call the user access layer. So in terms of very easily to understand, we have the getting data in, which is all about data warehousing, which is a problem that in terms of technology-oriented thing, it's not an issue, but there are some other issues to implement this kind of repository. So we are integrated data from different source systems into a central repository. That's getting data in. But it's no use to make decisions if we cannot take the data out. So when we take the data out, that's when we have business intelligence. That's when we start getting insight into what the data that we have. And again, it's very much linked to our targets, to our organizational goals. So, and we have all the different sort of BI applications like that have different possibilities like reporting, OLAP querying, predictive analytics, and so that's and this is a field that's growing very fast. So, what about the critical success factors? Well, we all know that doing this, I call it a DW, BI, Data Warehouse BI program, because it's not going to stop being built. It's very much like an infrastructure project, so we'll be building it project by project, but we need to continue investing in this program. So it's expensive on one hand, it's risky, but when it is successful, it really pays off and gives us a high return to the organization. When we go to the literature and see about critical success factors for BI initiatives, they are often described in terms of factors of failure, on the other way around. So we see that if we avoid those factors, these points of failure, we could actually achieve some of the benefits, which is time savings in terms of for data, for suppliers, for users, cost savings, and better decisions. We know that in terms of these, in studying the critical success factors for different organizations and across different industries, we see that there are a lot of existing studies focus on, for instance, a case study on a particular organization, or there are a lot of contributions from practitioners in the area, but there's not a lot of solid research on the critical success factors. And there is very, very little information about the critical success factors in higher ed. And we all know that higher ed is a specific type of, with a different context than, for instance, a private organization like a bank or insurance company. These are totally different organizations. So in terms of the most common reasons of failure across industries that are reported are weak sponsorship and management support, insufficient funding, of course it's complicated, inadequate user involvement, and hence much of the agile opportunity now, because we are using a lot of agile thinking, design thinking to get users involved in order to overcome this point of failure. And organizational politics, and here we are, this is critical for universities because we are very, very old institutions with a very, 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 very resistance to change. So how do we implement this? How do we get these incredibly great ideas and systems that technologically are already happening in the market? How do we make it happen here in our campuses? So what I'm bringing you today is a model of data warehouse success proposed by Professors Wixom and Watson. And what they did a different study. And it's one of the few studies that I found which is not based on one organization or a set of small organizations. They actually used the contacts of a lot of BI managers from the TDWI conferences, from the Data Warehouse Institute conference. And so they actually ran a survey, which they got 111 organizations to participate. Well, mostly the sample is from the US and Austria. It's interesting. And what they act in terms of industry, so we see that education is not really well represented in the sample. So we still need to look deeper into the success factors in higher ed. That's one of the things in the BI task force we want to do. And so they actually draw this model for data warehouse or BI success in terms of implementation factors. We have management support, the champion resources, people, time, cost, user participation, team skills, source systems, and then development technology, which then lead to implementation success. So these arrows, they actually match to hypotheses that they actually made, that management support is a driver for organizational implementation success, which then is a driver for data quality and system quality. So we have implementation factors, implementation success, and system success. And overall, the system success described by data quality and system quality would lead to the perceived net benefits of a BI, data warehouse BI initiative. So in terms of the study and the sample they had, these were the hypotheses that became true, that were validated, which is an interesting result because we all know that management support is key, but the champion and data quality are key aspects, although they were not perceived as key in this study. We certainly know that for higher education, we need a champion because of our organizational politics, because of the freedom, academic freedom. We do need a champion to power this sort of implementation, this sort of systems. And they also acknowledge that they do need to look more into the data quality issues and understand better the questions to understand why this sort of hypothesis did not come true. So what we have done in the BI task force was use maturity models. We did not use that model. We are now combining the two. But initially what we did was use maturity models, which are used in different areas. And they are a very, very good tool to assess the as-is situation of an organization in terms of their strengths and weaknesses. So typically, there are a lot of models, and they all have dimensions, and they have a sequence of levels, or stages. And it's supposed that an organization should climb each stage in order to achieve a higher stage of maturity. So there are many more. So there are a lot of maturity models for different areas, even for preservation. And these are some BI-specific maturity models. We have used these two. The first one is the one from the Data Warehouse Institute, the TDWI maturity model. And this other one was actually made during the course of between 2 years ago from OCU, with a consortium in Spain. And also one of the person now that is at Purdue University, which has been recently hired for the BI Competence Center director. He was also participating in this previous university, and then 2 universities from the States, and 1 university from Germany, and OCU, which is the Spanish consortium for Oficina de Corporación Universitaria. So they actually develop information systems for universities in Spain. And they developed this lean approach to develop, to calculate, and to assess the maturity for higher ed. So this one is specific for higher ed. The other ones can be used in every industry. So what did we do? So we actually got the perspective from 9 countries. We addressed the questionnaires to IT directors and CIOs, mostly. Whenever there was a BI manager, we addressed it to him, but there was most of the times there was not the case. Or if we could not contact the IT directors, we would contact directory level. Who promoted the questionnaires in each country? The local members of the UNIS BI task force in each country. I did it for Portugal, and others did it for the other countries. So in terms of collaboration, UNIS is all about collaboration. So we actually used the Almalare platform to run the survey. Almalare is also a university consortium in Italy that deals with employability and follow-up of graduates through their life. So we actually use them, and they are very active in the BI task force as well. So we use both models, as I said. The TDWI model was used with permission, and we did small adjustments to the questions because we wanted to reflect the higher ed terminology more closely. And we're going to see that in terms of the results, this is a key aspect. Because higher ed is a little bit different terminology and context than the organizations in private organizations. And the other one, the new higher ed specific maturity model, representing this work that's been done by these universities that I've just told you, with very dense model, with 9 questions and 9 dimensions. So for each dimension, only 1 question, like this. So instead of breaking down, well, it's two different approaches. Two different approaches. That's why in June we're going to have a very long discussion to understand which of the models are better. So with the original TDWI survey, it has 40 questions, 5 questions for each 8 dimensions, for each dimension. So it's better. But it's easier, we think, but we still need to validate. And you're going to see the results and understand why I'm saying this. So in terms of the global response, we have a global response of 66 in the 9 countries, mostly public higher education institutions. And you see the distribution of answers per country. Actually, the UK and Ireland were the last to join. They were very fast because you are very organized in terms of the mailing list that you have, the contact persons. For instance, for Portugal, what I had to do, I had to call. I called each IT director, and I got the answer, I got the okay. But imagine German, 250, I think, or more institutions. It's quite complicated to do that. So Ireland, you are fairly few institutions, so it's easy to understand this vision. In terms of the number of years that they have in terms of experience, we see here 18% have not yet started. Less than 1 year, 11%. 1 to 2.5 years, 12%. And so this is very, very interesting. So we're talking about this. We're talking about data. We have a lot of data. Have they started? No. So when are we going to start? That's really my question. And those who have started are very, very few. Some in Italy, in Germany. There are very interesting case studies. Don't know, which is a good answer in this case. So the number of full-time equivalent BIDW staff members, including contractors. What can we do to tackle this problem with none, 1, 2, or 5 full-time employees? This is a wake-up call because we actually needed to. People ask me what we can do, what EUNIS can do, and what the BI task force can do. Well, the first thing is to know where we are. Where we are is in the beginning, with a lot of interesting ideas, with a lot of challenges ahead, but we need to start. And if we want to start, this is the idea of the survey. We do not have to make the same mistakes that organizations that have done this road 20 years ago have done. So all that we have to do now is take on the good lessons and move quicker. So in terms of the maturity model, I'm not going to go into the details very much because I would not be able to do it in 20 minutes. The DWI model has 8 dimensions. You see scope, sponsorship, funding, value, architecture, data, development, and delivery. And also 5 stages of maturity. So we have here the non-existent, the first stage, and then we go into the preliminary stage, repeatable, manage, and optimize. These 2 gaps over here, it's a reminder, it's very well studied as well. We can go back. We can always go back. And there are some problems here that we need to overcome. So in terms of scope, just to give you an idea, the questions go roundabout to understand to what extent does the BIDW program support all parts of the organization and all potential users? Is it a narrow initiative or is it an organizational-wide initiative? Is it just financial? Do you just have decision support for financial data? Which is the most critical data for you? Sponsorship. To what degree are BIDW sponsors engaged and committed to the program? Funding. how successful is the BIDW team in securing funding to meet business requirements? So how successful are they to, for instance, the IT services to secure funding for having one full-time person developing these systems? And one is certainly not enough. If we want to achieve, for instance, what Purdue has achieved. If we look at Purdue University, they have a BI competence center. And they have a huge team behind. So that's why it works. Value. How effectively does the BIDW solution meet business needs and expectations? It needs to result in value. Architecture. Again, we should follow standards. Our line and our advance are the BI architecture system aligned with the standards of the industry. We have 20 years of experience. The challenges now are to integrate big data into the old architecture of data warehouses. But that's a challenge now. So data, to what degree does the data provided by the BIDW environment meet business requirements? Again, data quality, data accessibility. Do the users get the data that they need when they need it? Can they rely? Do we have confidence on the data? Because if we don't, all of this is useless. Development. How effective is the BIDW team's approach to managing projects and developing solutions? We need to keep the pace of developing. Once we get to users, they need to see updates. They need to see new developments. That's why it's a program. We need to, the more agile we are, the better. Delivery. How aligned are reporting analysis capabilities with user requirements, and what is the extent of usage? Okay, so we did everything. We have now integrated data, we align with standards, we did everything, we delivered. Do they use it? Do we measure if they use it? Because if they're not using it, they're making decisions based on other data, or what are they doing? So delivery. Delivery is key, value is key, data is key. Funding is critical. Everything is critical, okay? So based on the scores, and everyone can take this test because the scores are available. Based on the scores of the questions, you actually calculate in which of the stage you are in. So we presented these preliminary results at a BI conference in March, which was a very, very interesting conference because we had 70 participants from 15 countries. Amazing. Amazing. 40% of the persons that were there have not yet started their BI initiative. So there's a huge amount of need in terms of training, in terms of talking about these issues. And so this is the overall analysis, the results. 9 countries. Lots of blues, right? There's only one, because this is only one institution. One. And so delivery is key, right? Development, delivery, are they using it? Funding, value, scope. Okay. What we did is, so I get, in terms of the colors, I'm going to show you the analysis for each of the countries. And then I go back. We skip Finland because it's only one university. It needs to be more addressed in that country. It's not representative. France is really just starting. Ireland and UK. That's why we're now going to have local meetings within each country to understand and study these results. My initial idea is that there are very contradictory results. For instance, they have not developed, so they did not deliver it, but they are using it. And no problem with funding, but they have not developed. And the scope, And what about UK? They're struggling, but there's still delivery. How can there be a delivery here, the usage, when there's a value? So the thing is that what we think about when we see these results is that the maturity level of IT services and the rectory as well is fairly low in understanding the questionnaire itself and the concepts. So that's why we're now trying to work on the critical success factors, because they're all linked to the questions that we ask to assess maturity. And try to train and to communicate in order to get better answers. This is a starting point. This is the current status. The current status is that we need to do a lot. We need to do a lot to understand how we can improve. And there's definitely a path to improvement, and we can do it fast, very fast. I believe so. For instance, even in Germany, which has a lot of very interesting case studies, in Italy, they are struggling a lot. They are struggling with funding, with data, with development, with delivery, but the value, oh, they are good. So you see, this is contradictory. So that's why we need to get in touch with the local universities in each country and understand why they did it in such a way, why they answered like that. So in terms of concluding remarks, we have gathered the first data to enable us to compile the current status of BI initiatives in 9 countries in Europe. We can actually, every institution that participates or who has not yet participated can actually use the survey and benchmark its maturity across this average score. So the survey was completely anonymous, and we will maintain it like that in the next edition as well. What we are, as I said, we are doing national events at the BI Taskforce, and I encourage you all to participate. And if you are part of an institution, a university, and if you want to join our task force, you are most welcome. I will leave my contacts in the end. And we are also doing a lot of training and communication to ensure that the next edition of the survey is more reliable in terms of the answers. And by all means, if you want to start this sort of system, a BI or DW initiative, and if you need help, contact us. And because we are there too, we have a site, and what we are doing is actually promoting and created this online platform to exchange case studies. We have some case studies from the US. We have a close collaboration with the US as well, with the Higher Education Data Warehouse Forum, which is very similar to the BI Task Force, but like 20 years ahead of us. And so we are collaborating a lot so that Europe can gain more insight about what they did best in the US, and vice versa as well. Okay, so that's it for me.
So, any questions for Elsa? Yep. Oh, there's a mic coming.
Thank you, Elsa. Alex Reid from ARNet and also University of Western Australia. I'm intrigued by your surprise at how few universities seem to be doing BI. I just wonder if this is not perhaps a matter of definition. At my university, we don't call it BI. We call it, we've had one for years. We call it the statistics unit or the corporate statistics entity or whatever, because all universities these days have to report statistics, student statistics, to government, so they all have a unit of some kind. Is it perhaps not just that they don't use the term BI?
It could be. It could be. They have a planning office, but they all do statistics. But I'm not sure the degree of confidence you have in your statistics. I know that I don't trust very much my statistics. So that's what I'm talking about. We do it for with papers. We're doing it for, it depends how they do it. Yes, they do have to report. Yes. So now the strength is that we have to report more often. And I haven't said, but one of the drives that are compelling universities to build this sort of systems is that they have to report more often for the ministry, for society as well. Students are more demanding as well. And so in Portugal, for instance, we have a lot of an accreditation process, which is very, very demanding. And we have to provide reports every year. And if the procedure is not automated, there are no resources to do it. So the thing is that, of course, they have been reporting for years, but also the quality of the data, if we want to compare. I know that Australia, and I'm not, from which university are you?
Western Australia.
Western Australia, yeah. Some of them are very, well, they have very, very interesting systems already doing it. But the thing is that in some countries, that's not the case. That's not the case. I'm not surprised. I knew it was going to be like this. But the thing is that but it's much, we all know, but when we see it, when we see a picture, then something needs to change. Something needs to change. We need the funding, we need the resources to actually build this system. And it's not just about statistics. It's not having what they call it, an institutional research office sometimes, or we need more. We need integrated data. Do you have integrated data? For how long back do you trust your data to see trends? As Vitoriano was asking, how long do we know and can we trust the data that we have in our student records? For how long? 5 years? Well, institutions have been operating for hundreds of years.
Yep.
So the thing is that, yeah, it's all about the term, but it's the term that the market uses. It's just a name. That's why I started with the definition. It's just a name. We can call it decision support systems. We can call it whatever. It's just a name.
There's another question.
Hello, my name is Olav Isak Sjøflot from Uninet in Norway. I was just curious, you mentioned this indirectly, I think, in your talk, this kind of reluctance to change in our sector. What is the willingness to adapt to a common regime here? Will it often be a case of like the not invented here syndrome? If you come up with a kind of a common scheme, a common BI setup to use across the institutions?
I didn't get, can you?
You didn't get my case? Okay.
No.
If you come up with a common set of measures and a common way to set up a BI system, and you try to make a one-size-fits-all for all institutions?
It's not going to work.
No.
It's not going to work. First of all, we're not the US. We are in Europe. We are totally different countries with different needs. And with different regulations, with different laws, so with different compliance systems. So what we know, and that's hence the task force. What we're doing is know that if we want to analyze student data, there are basic KPIs that we're going to use. So why not share? Why not share the models? Why not share the KPIs, the definition? Because that's the thing that in the US they try to do it with the Data Warehouse Forum, but fail to do it because it's on a voluntary basis. So it needs resources. We need resources. That's the thing. So that's what we want to do. There is a common thing, but the thing is that we cannot buy one of these systems. It needs to be adapted to our university, to our settings, to our culture, to our needs.
Undoubtedly hard problems, but I'll have to cut this short, I'm afraid. You guys will have to slug it out in the break. Right now, we're at 1 minute before we're supposed to